You're asking me to think back a long way now, eh?
Yeah, yeah.
This was all in, I mean, we were working on hydrogen as a means of processing magnets way back in the 1960s and 70s. We worked on samarium cobalt 5 and 217 magnets initially, and found that the system, you know, the process could be used quite effectively for these materials. And then when neodymium ion boron came along in early 80s, 1983, 1984, we immediately switched our attention to looking at these materials, and found that really it was absolutely ideal as a means of producing fine powder. We then set up, I mean, I was part of a process of Runi Potonnet was the main coordinator from France, and that followed on by Mike Coey from Trinity College Dublin. And we all set up the Concerted European Action on Magnets, CEAM program. And so we were able to coordinate the European activities very effectively under this umbrella. And so the work went on really very much faster, I think, and more effectively as part of the CEAM program. So we worked, for instance, with Philips and with the people at Philips in Southport and Rosendahl, Iwo Rosendahl, who was really quite a genius at taking an idea such as hydrogen decrepitation and then making it work in an industrial environment, and that's what happened. So it really worked extremely well, and then, because as you know later on, it developed into a possibility of using it for recycling as well, which is now part of Alan Walton's program here in Birmingham and part of your exercise, of course, in EREAN. Well, the beauty of hydrogen, and you know, is that you should look at it again in a holistic way, because hydrogen, I strongly believe and hope that hydrogen will be part of our energy mix. It turns out that hydrogen can be used to store energy from sustainable sources such as wind and solar and tidal and so on. So hydrogen as a fuel and as a storage medium is also as important as hydrogen as a processing tool. So you know, you have to look at all these things together. But I think as part of the recycling program, it will again be a very important aspect of that activity. It allows you to produce powder in a reducing environment, you know, so that you can not eliminate maybe altogether, but certainly reduce the problem of oxidation of the powders. And again, you know, means that you can recycle and use the magnets again, maybe with reduced properties, but even so, significantly better than any alternative. So that again is something one should look at, and I think the whole system is really extremely promising. And it's good to see, as we did with CEAM all those years ago, it's now part of a joint European program again, and I think this is where Europe has a major role to play in coordinating the technological expertise within all the member countries, and it's very nice to see this. The beauty about neodymium ion boron is that if you expose the cast alloy to hydrogen at room temperature, it will activate and absorb the hydrogen. And this is true both of the basic cast ingot material and also of the sintered magnets as well. And this means that you are getting a process going on which involves the separation of the material then into fine particulate form by initially the hydrogen being absorbed at the grain boundaries, which are neodymium rich, and then subsequently into the matrix phase, the NdFeB. And the consequence of this is that you get this very fine powder produced. It's not fine enough to make magnets directly from the powder, but then the powder itself is extremely friable, which means that you can mill it to a reduced level very quickly using, say, jet milling or whatever. And hydrogen has done a lot of the work for you, and this means it is very attractive from an energy point of view. But the other thing that we still have to exploit is that hydrogen is dissolved from the material during the sintering process. So we have hydrogen that can either be recycled and used again, or can be used as a fuel in a separate application. So, you know, we need to look at this in a whole area, sort of from grave to, what's the word you use, you know, when you look at life cycle analysis, the whole thing. And when you look at then, in that possibility, then hydrogen becomes remarkably important.